Hello everyone, I am Dr. Mehar Chand and I am very happy to welcome you to today's session on one of the most fascinating ideas in the world of artificial intelligence, the concept of artificial neural networks, or shortly ANN. Before we get into the definition or technical diagram, I want to begin with a very simple story. Imagine a small child around 2 years old. This child has never seen a dog before. One day you take the child outside and a dog walks by. You say, "Look, that is a dog." The next day you meet another dog, different color, different size, and again you say, "That is also a dog." After saying this a few times, the child starts saying dog. Even when you did not tell them the answer, how did this child learn? You did not give any formula, you did not explain features, you did not describe that four legs or or a tail or ears look like. The child simply learned from patterns through repeated exposure. Artificial neural network do something very similar. They learn from pattern examples, they improve through experience, and they become smarter over time. And today we are going to explore this beautiful journey of how ANN learn, how they think, and how they help a machine behave like with some level of intelligence. So let's begin the journey. To understand ANN, I want you to imagine thousands of tiny light bulbs connected by wires. Each light bulb is like a neuron. Some bulbs glow brightly, some glow dimly, some stay off. The glowing depends on the information passing through. This entire network of light bulbs is like the artificial neural network. Why do we use networks? Because human intelligence does not come from a single neuron, it comes from the connections of billions of neurons. Similarly, ANN intelligence comes from how these artificial neurons connect and work together. In the early days of the computing, machine followed a strict rule. If condition A happen, do action B. If condition C happen, do action D. Very rigid. But ANN changed this idea. Instead of following a fixed rule, ANN model learn from the data. They learn from images, sounds, text, numbers, almost everything. Think of the application around you. When your phone unlock using your face, when YouTube suggests a video, when Google photo group images of your family, when doctors detect disease using medical scans, all these depend upon ANN. So the basic idea is simple. Artificial neural networks are computational systems designed to think and learn in a way inspired by how the human brain functions. To truly appreciate ANN, let's back to the biology, the human brain. Your brain contains around 86 billion neurons. Each neuron is connected to thousands of others. These connections are called synapses. Let's break this biological inspiration into three simple elements. Very first is the signal. Neurons communicate using electrical and chemical signals. This signal travel extremely fast, allowing you to react, think, and understand the world instantly. Second, we have is the synapses. Imagine synapses as a bridge. The bridge is strong, signals pass easily. Sometimes the bridge is weak, signals fade. When you learn something new, your brain strengthens synapses. When you forget something, those synapses weaken. And third one we have is the neurons. Neurons are the workers of the brain. They receive input, process it, and send results to the next neurons. Now, how does this related to ANN? Well, we create artificial version of all these artificial neurons, artificial synapses, artificial signals. We use the mathematical formula to simulate way neurons behave in the brain. This biological inspiration is the reason ANN are so powerful. They borrow learning mechanism directly from the human intelligence. Now let's look at the structure of ANN. Remember the network of the light. Let's organize them into three big groups. Very first is the input layer. This is where information enters the network. If you are giving an image, each pixel becomes a number. and enters through the input nodes. It is like your eyes sending signal to your brain. Second one is the most important, hidden layer. This is where learning happens. Hidden layers are like a secret room where data gets transformed. Each layer extracts something useful. One layer detects the edges, another layer detects shapes, next layer detects patterns, and the final layer understands the complete object. Imagine teaching someone to draw. The first draw the simple line, then shape, then details, and finally draw the full picture. Hidden layers do exactly this step by step in the machine learning. And last one we have is the output layer. This is the final answer. Is this a cat? Is this a dog? Is the sentiment positive or negative? What we will stock price be tomorrow? The output layer is like your brain concluding, yes, I recognize this. This entire flow from input to hidden layer to output from the architecture of the ANN. Now let's go back to our story of the child learning animal. When the child makes a mistake, the parents correct them. Slowly the child's understand improve. The same thing happen in the ANN. In the very first step, ANN make guesses. Suppose we show an image of a cat. The ANN might guesses dog. That is okay. It is learning. In the second step, backpropagation. Now comes the key step. The network compare its guesses with the correct answer and calculate how wrong it was. This error is thus sent to backward through the network. Every connection that contributed to the mistake gets adjusted. Think of it like the teacher explaining, you made this mistake because you misunderstand this part, fix this. Next, third step we have is the weight update. The strength of the connection called weight gets updated. Some became stronger, some weaker. In the step 4, minimization, over the time ANN makes fewer mistakes. It gradually improves until it becomes highly accurate. This learning process is repeated thousands or even millions of times, and with each repetition the ANN become more intelligent. This is how ANN learns, slowly, patiently, by refining connections, just like our brain. Now let's look at why ANN are so important in the machine learning. Very first we have is the pattern detection and recognition. ANN are excellent at recognizing pattern, faces, voices, object handwriting. They learn patterns that humans cannot explicitly define. No linear data modeling. Real world data is messy and complicated. ANN can understand relationship and are non-linear, unpredictable and complex. Next we have is the large scale data processing. Today's data is massive, millions of images, billions of words. ANN can handle such a large dataset efficiently. This makes ANN the backbone of modern machine learning. When you give a ANN raw data, an image, a sound or a sentence, it doesn't panic. Instead, it begins to organize the data automatically. ANN remove unnecessary noise and focus on what matters. Next we have is the abstraction. They convert pixels into the edges, edges into the shape, shape into the object, object into meaning. In hierarchy, every layers learn a deeper level of the understanding. This is very similar to human brain. From simple idea to the complex concept, this ability to automatically extract features is what makes ANN incredibly powerful and efficient. ANN are not just good with the images, they also understand sequences, information that unfolds over time. In language, when you type a sentence and your phone predicts the next word, ANN is working. When AI translates language, it follows patterns learned from millions of the sentences. In speech, when your phone converts your voice into the text, it is recognizing spoken pattern, accent and tone, all using artificial neural network. And in the time series data, stock market, weather pattern, patient health reading, all follows a sequence over time. ANN like RNN and LSTM are designed specifically to understand such time based data. Sequential learning is essential for many real world systems, and ANN handles it brilliantly. ANN also play a huge role in intelligent decision making system, just like autonomous driving system. Self-driving cars use ANN to recognize roads, signs, like pedestrians, and even predict what nearby vehicle will do. ANN process information in real time and help the car make self-decision. Robotics and automation. Modern robot can pick up object, detect object, assemble machine, and even assist in surgeries, all using ANN based perception and decision making. Last one we have is the reinforcement learning. In games like chess or Go, ANN learns strategies through trial and error. It tries, fails, tries again, and improve until it becomes better than human expert. ANN are not just analyzing; they are making decisions based on learned experience. We have some real world applications of artificial neural network, and let's look at where ANN are making the big impact in the society. Very first is the vision. Formal facial recognition to the medical images diagnosis. ANN can see patterns that humans might miss. Second we have is the natural language processing, and shortly we can say NLP. ANN helps computers understand human language, just like chatbot, translation, sentiment analysis, humanization, all rely on ANN. Next, we have the huge application in the healthcare. ANN can detect disease earlier than humans in some cases. It assists in analyzing X-rays, MRI scans, genetic data, and predicting treatment outcomes. In finance, a bank uses ANN to detect fraud. Investment companies use ANN for the algorithm trading. Risk analysis and credit scoring are increasingly ANN driven. ANN is transforming almost every industry it touches. Now, there are several significances of the artificial neural network. Now let's understand why ANN is so significant in the modern AI. Very first is the generalization. ANN can learn from past data and apply that knowledge to the new simulation, new situation. Adaptability, they improve over time with more data. Scalability, ANN can handle small problems and also extremely large global scale problems, and this is the foundation of the deep learning. Most of today's breakthrough, self-driving cars, ChatGPT, medical AI, robotics, are built on deep neural network. Without artificial neural network, modern artificial intelligence would not exist. Thank you for listening. We explored artificial neural network through stories, simple explanations, and real-world examples. ANN are revolutionizing every aspect of the technologies by enabling machine to learn, adapt, and make intelligent decisions. As we move forward, ANN will continue shaping the future of artificial intelligence. Thank you once again. Let's continue exploring the world of AI together. Thank you.